Alrighty. So, what did we do yesterday? We did decimal operations, right? What type of operations did we do? Adding and subtracting decimals. What was the rule that we took away from yesterday when you add or subtract decimals? If you're given a problem like this, what you must always do is line up the decimals vertically. So 2.5, 0.367, and add them, right? First you must add the zeros, and now you just add it. Add its place values. So you got to add that, and then so on and so forth. The decimal will come down right there. That's the rule that we took away from adding and subtracting decimals, right? Do we know what we're doing today?
Dividing decimals.
And multiplying. So today we're going to do a lot of stuff. A lot of problems and examples to help you understand how to multiply and divide decimals. And then guess what we're doing tomorrow? Quiz. Cool. So today we're going over multiplying and dividing decimals. So if you're given something like this, hey. The question is, find the product of 2.6 and 0.45. Find the product of 2.6 and 0.45. What does that mean?
Multiply.
Product means multiplication, right? So find the product of 2.6 and 0.45. So we have to set it up as a multiplication problem, right? Do we line up the decimals in multiplication?
Yeah.
We did an adding and subtracting, so why not multiplication, right? Guess what? No, you don't line up the decimals when multiplying. What you end up doing, this is the rule for multiplying, you ignore the decimal. And what you do is just treat it as whole numbers. If the decimal wasn't there, what would be the whole number? 26, right? 26. If we ignore the decimal there, what would be the whole number? 45. So what you do when multiplying decimals is ignore it just for 2 seconds. Just for 2 seconds while you solve it by hand, as if it were whole numbers. Do we remember how to solve multiplication problems by hand? Alrighty. What must we do? We must multiply the 5 outwards, right? So let's do the first one. What's 5 times 6? What is 5 times 2? Plus 3. We remember this, right? Multiplying by hands. If we remember it so much, when we move on to the next digit, the 4, and multiply the 4 outwards, what must we do first? And erase any carryovers that you did from the digit before, right? So now we do that. What's 4 times 6? What's 4 times 2? Plus 2. Ten. You add them up, what do we get? 0 plus 0, 0. 3 plus 4, 1 plus 0, and 1 plus 0. So 26 times 45 is 1,170, right? But now we include the decimal. Now what we do is we ask ourselves something. We ask ourselves, how many steps does it take to get our original problems, our original 2.6? How many steps does it take to get that decimal to the end here?
1.
Well, you go to it, and then you go, boom, 1, right? It takes 1 step to move the decimal of 2.6 to the end. 1. How many steps does it take to get this 0.45 to its decimal to the end? 1, 2, right? 2. And yes, you add those. What's 1 plus 2? 3. This is the amount of steps you go into your answer to place the decimal. So all you do is go to your answer, 1170, right? Start at the end, and then count. 1, 2, 3. Boom, that's where my decimal is. The answer, the product of 2.6 and 0.45 is 1.170 or 1.17 because obviously you don't need any zeros. Did that make sense? Gotta love decimals. Why what? Don't ever ask why. Why do we gotta love decimals? It's because decimals are part of everything. And those of you that are taking your GED, like I said a million times, the first 5 questions you are not allowed to use the calculator, right? Which means they're gonna throw stuff that you would be able to easily solve with a calculator. They'll throw that at you knowing that you aren't allowed to use the calculator. So they want to see whether you know how to do it by hand. So chances are they'll give you seriously a question like this. What is the product of 2.6 and 0.45? And then they'll see whether you know how to do it, or if you guess and then move on, that means you never learned how to do multiplying decimals by hand. Alrighty. Do you want to do one more of multiplication? What if we do, I'll just set it up right off the bat. What is the product of, actually I won't set it up. What is the product of 3.160 actually 8 and this is a bad example, but we're going to do it. It's going to be a long one. So, what did I say the rule was when multiplying decimals?
Line them up.
Line what up?
The numbers.
Without the decimals. Good. So ignore the decimals. Treat it as if they were whole numbers, right? 318 and 205. So, okay. Let's do this. It's going to be a long one, but we can do this. What's 8 times 5? 5 times 1 plus 4. What's 5 times 3? Cool. 5 is done, which means I erase any carryovers and I move on down to my 0. But what must I do first? Add the 0. Okay, now, what's 0 times 8? 0. What's 0 times 1? What's 0 times 3? That's the beauty of 0. Multiplying zeros, so nice. Okay, so now I'm moving on to my 2. If I move on to my 2, erase any carryovers, which we didn't. But now what must you do? 2 zeros. Now, what's 2 times 8? My gosh. 16. What is 2 times 1? Plus 1. What's 2 times 3? Add everything. What is 0 plus 0 plus 0? What's 9 plus 0 plus 0? What's 5 plus 6? What's 1 plus 1 plus 3? What's 6 plus 0 plus 0? Cool, 65,190. It needs a decimal. So you know what I do? I go back to my original problem, look at their decimals, there's one there, there's one there, and ask myself, how many steps does it take?
3.
This one is 2 steps, this one is 1 step, a total of 3, so guess what? I start at the end right there, and then I count 1, 2, 3. 65.19 is my final answer. Crazy, huh? You don't need it. Remember, we have an infinite amount of zeros behind it. We take it off because we do not need it. So 65.19 is your answer. 65.190 is your answer also, but that's not what you're going to see in your answers, under your multiple choice answers. Nice. Multiplication done, right? What's the rule that we took away from it? Ignore the decimal. Just multiply it as if they were whole numbers. Then at the end, count the steps it takes to get the decimal to the end of each original decimal number. And then place that decimal in the total amount of steps you calculated. Okay, now comes the beast, division, dividing decimals. So here we have something like this. Divide 4.9 by 0.35. Do we know what to do? Divide 4.9 by 0.35.
Is that a 6G?
By.
Sorry.
You know what? You hurt my feelings. I'm going to do something different.
No.
Yes. There's a reason why. Save that one because we're going to come back to it. But there is one that you need to know before. That was the most challenging one. All right, we're going to do something a little bit more simpler. By 6. So you set it up as a division problem, right? 14.4 divided by 6. Yeah. Yeah, we haven't learned any rules yet. This is the thing. You have to ask yourself, is the outside number a whole number or a decimal? It's a whole number, right? It doesn't have a decimal. Those are the ones that are your best friends. Those are the simpler ones. Why? Because the rule with these type of division problems is this. Ignore the decimal. Right? Well, don't really ignore it. What you're going to do is place it up. You're just going to place it right there because your answer will have the decimal right there. Right? But now you could technically ignore it. Just treat this as 144. Right? And do stuff step by step if we recall our division techniques. How many times does 6 fit into 1? 1. How many times does 6 fit into 1? Into 1. 0. Now comes your answer. How many times does 6 fit into 14?
2.
What did it become? 14 minus 12? 2. Okay. Bring down the next number. This is why I said ignore the decimal, right? Just bring down the next number. And now ask yourself, how many times does 6 fit into 24?
4.
Creating. When you subtract that, oh, look at that, 0. That's what you're always looking for, right? 2.4 is my answer. So if you notice, it's literally the same as dividing whole numbers. You just have to remember that wherever the decimal is, you just place it at the top. And that's only because my outside number is a whole number, right?
I might have to put the decimal on the top between, like, I have to have 2 numbers and then the decimal, or
No, the decimal could be anywhere. The decimal could be anywhere. If you're given this 3 and 0.56, guess what? The decimal is going to go right there, right? Your answer will have a decimal right there. And now you just ask yourself, how many times does 3 fit into 5? Once, right? And then so on and so forth.
yeah, but because you put it first,
Yeah.
in the numbers.
Yeah. In that example, yes. But the decimal could be anywhere. If it's on the inside, it could be anywhere. All you do is just shoot it up. That's where your answer will have its decimal right there. But again, only because the outside is a whole number. Now comes the one that I wrote originally. 4.9 by 0.35. How do you write that? .35, right? So now, is the outside number, is it a whole number or a decimal? Yes, it is a decimal, right? So if you ever spot that the outside number is the decimal, what you must do is ask yourself, or not ask yourself, but do this. Move the decimal place all the way to the end of that number, right? And then keep track of the steps. How many steps did you move that decimal point to get it to the end of the 5? How many steps? 2. Right, Nan? 2. We moved it 2 places, right? The decimal on the outside, we moved it 2 places. 1, 2, to get it to this end right there. So now, yes, it's a 35. But do you know what you got to do now? Is if you move this one 2 places, you must now go to the inside and move it 2 places. 1, 2. There's my decimal. Now my answer is going to have its decimal place right there. Now it just became a straight up long division. Oh man, hold on. So, oh. I will get this. No, I won't. Okay. Let's do this. How many times does 35 fit into 49? Actually, I'm tedious. I'm really a perfectionist. I want to do this step by step. How many times does 35 fit into 4?
0.
So you put that. Now ask yourself, how many times does 35 fit into 49?
1.
Creating 35, right? What's your remainder?
4.
14. And then next step, bring the 0 down. How many times does 35 fit into 140?
3.
Close.
4.
4. Creating 140. So 4 times 35 is 140. With the remainder 0. Oops. The answer is, in this specific case, we didn't even have to continue on with any sort of numbers, any 3, 2, nothing. This ended up becoming a perfect whole number of 14. Right? But if it were to have continued on, let's say by some weird situation we had a remainder of 3, what would we have to do next? Create a 0, bring it down, and then ask yourself how many times does 35 fit into 30? 0 times. So then we bring it down, 0. Ask yourself how many times does 35 fit into 300? Blah, 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 blah. I don't care, right? But if you notice that decimal place that we originally placed there is where the answer would have its decimal place. So, review. If the outside number is a whole number, literally just start dividing. Put the decimal place, just shoot it straight up, because that's where your answer's decimal will be at. If your outside number has a decimal there, you have to make the outside number into a whole number by moving its decimal place. However amount of steps you moved it, you must do that same thing on the inside. And then you create this, and then wherever the decimal place lands on the inside, that's where your answer's decimal place is going to be. Right there. In this case, it just came out 14.00000, right? Which is the same as saying 14. Did that make sense? So we went over multiplication and division. Are we ready to test out our skills with some practice problems? Please ask for help. Please ask for help. Because tomorrow is the quiz, and you guys have the luxury of being the only ones here, which means you guys have the luxury of taking advantage of me before the quiz. We got it, Nan? Got it, Rua? Laura? Veronica? These are my 4-star students. It's going on YouTube.